Hello guys, so let's discuss problem 3346, that is maximum frequency of an element after performing operations 1. So it is a part 1 and it is marked as medium. You are given an integer array nums and two integers k and num operations. You must perform an operation num operations time on nums, where in each operation you select an index I that was not selected in any previous operations. Add an integer in the range -k to k to nums I. Return the maximum possible frequency of any element in nums after performing the operations. So we have to do the operations that are defined as we can add -k to k to any element which is not previously selected, means in which we have not done operations yet. And at last we have to return the maximum possible frequency of any element that we can make after doing these operations. So the the constraints are huge, so we have to find a solution in O of n or O of n log n approximately. So what we can do is we have to find the frequency. So let's understand it by taking the second example, given example, that is 5, 11, 20 and 20. Now we have to do operations in the elements in which we can add -5. The k value is 5, so we can add -5 to 5, any value. Means we can add -4, -3, 1, 2, 3, 4 till 5. So if we add, so the minimum we can get by doing operation is -5, and the maximum we can get is 10. So we can get any element in this range -5 to 10 by doing operation. Similarly, in this we can, in 11 we can get 6 to 16, any element between 6 to 16 in this range. So what we can do is we can store the frequencies, that how many elements we can get, how many particular elements we can get. And so let's discuss 0, 1, 2, 2, 3, 4, 5, 6, 7. So 0 we can get from here also, so its frequency will be 1, and 0 we cannot get from any other element, and 1 we can get from here, and we cannot get from any elements. Similarly, 2 from this, 3 from this, 4 also from the first element, and 5 also from the first element we can get. And we can also get 6 from the first element and from the second element we can get. So the frequency will be 2. Similarly, 7 we can get from the first element and from the second element. So the frequency of 7 will be 2. Similarly, we will do all other operations in these elements, and we can get the frequency of other numbers also, like 8, 9, 10. We can get the these frequencies similarly like this. So the first thing is what we can do is we have to define a range, means -5 to 10, 6 to 16, similarly 15 to 25, 15 to 25. We have to define a range. Since the nums length is maximum 10 raised to the power 5, so what we can do is we can create a vector of length maximum element plus 2. Why maximum? Because why if the maximum element is 20, means we can make this number 20 also and greater than 20 also. So why we will make it to greater than 20 when we can make it to 20. Similarly, for the y, if I can make this element till 0, why I would make it to negative. So that's why the size of the vector will be maximum element plus 2. And yeah, so what I'm doing is I'm iterating in nums, and I'm creating the range L or R. This range is this -5 to 10, and I'm making this is similar to the prefix difference array that we create. So I'm creating the increasing the frequency at the lth number for the lth number, and doing it for decreasing it for the r plus 1th number. Means for 5 I'm increasing the frequency of 0, because I minus k will be 0. 5 minus 5, the ith is 5. So 5 minus 5 is 0, so the L will contain the 0. So increasing the frequency of 0, and r plus 1 it is 5 plus 5 10 plus 11th. 11th index will contain -1, so that when I when I will iterate in the difference array to get my cumulative sum, so that I can get the correct cumulative sum. That's why I'm decreasing this. And what other thing is I'm doing is I'm creating a frequency to store the frequency of already present element in our array. So this unordered map is for creating the frequency or for storing the frequency of the numbers. So yeah, I'm storing the frequency here, and then I'm iterating from 0 to maximum element that is present in my array. So I'm taking all these numbers as my target. Means I'm making this 0. How many zeros I can make from this number of operations, and how many frequencies are present of this 0. So I'm calculating for 0. Similarly for 1, 2, like this. So we can create it from 0 also, but I have started from 1. So the difference this is the cumulative sum. So difference I will hold the cumulative sum, and current target is our 0. But now what I am doing is num operations. What I am doing is how many conversions I can make. Means we have already for 5 we already have 5 present. Let's say for 20 we already have 20 presents in our array. So difference I will hold the current cumulative sum minus current cumulative sum, and the conversions, how many valid conversions we can make. Like we can only do one operations here, and the frequency of this 20 is 2. So difference I will hold. So this basically is the conversions. I hope you understand how we can explain it. Like see, like 6, the frequency of the difference array of 6 is plus 2. Yeah, it will hold 6 will hold 2. Yes. So basically here we are doing the conversions, like how many valid conversions we can do, and then at last we are updating our answers like valid conversions plus already present elements of that target element in our array. So this answer is holding our final answer, and at last we are returning our answer. So the time complexity for this approach is order of maximum element, that is maximum element will be 10 raised to the power 5. So the time complexity will be O of 10 raised to the power 5, and the space complexity will be O of n, because we are creating the one map and one vector, difference vector for storing So the time complexity will be order of n, order of maximum element, and the space complexity will be order of n. Yeah, that's all for this solution. Thank you.